Hey guys, it just occurred to me since I didn't have you guys last year that maybe your kinematics you're not real confident of. So I thought maybe on this problem for Bernoulli simulation part 2, number 18 through 20, maybe you needed a little bit of extra help. So you guys got to let me know whenever that happens, when I'm assuming that you know something you don't know. Okay, you shouldn't feel bad, you just need to let me know. Okay, so anyway, I'm going to see if I can help you out a little bit on this. So I've set up the picture of what's going on. So we got one of these sprinklers that's got 4 spigots on it, and it's shooting water out at a 35-degree angle, and it covers a range of 7 meters. We're trying to figure out the velocity of the water coming out of that sprinkler head. Okay, so what we need to look at is we need to analyze this motion both horizontally and we need to analyze it vertically. So let's start off with the horizontal motion. So horizontal. Okay, so when we're looking at the horizontal motion, would that be constant velocity or constant acceleration horizontally? Hopefully you're saying, well, there's no force horizontal, so assuming there's no air resistance. So that means it would be constant velocity model. So for horizontal, I'm going to put CV here. And that would be x equals v times the time. Now keep in mind that this velocity really it's coming out of the spigot at an angle. So really the horizontal velocity is just going to be a part of that velocity. So that's going to be given by trig. So it's actually going to be v cosine of 35 degrees, and that will be times the time. So now I do know what that distance is. That horizontal distance is 7 meters. But the problem is there's 2 unknowns here. I don't know what the velocity is or what the time is. So I'm going to set that aside. I have 1 equation, 2 unknowns. How many equations will I need? Hopefully you're saying, well, Mr. Lindfest, that's easy. 2 unknowns, I need to have 2 equations. So in order to get that second equation, we need to look at the vertical motion. So for the vertical motion, and I'm going to have the same question to you guys. For this vertical motion where it goes up and then it comes back down, we're going to assume that it comes back down the same amount. Of course, in reality, it goes down probably a little bit lower, but we're going to say that this is flush with the ground. So my question to you is, will this be constant velocity or will it be constant acceleration motion? If you're stuck on that, you need to be thinking, is there any forces acting on it, this vertical direction? And hopefully you're saying, yeah, there's the force of gravity acting on it. So this would be constant acceleration model. And the constant acceleration model is, instead of being x equals vt, it's going to be given by the other one, the vit plus 1/2 at squared, that kind of thing. So I'm going to write y, because we're looking at vertical motion here, equals the velocity times the time, plus 1/2 at squared, but the acceleration is in the opposite direction of the initial velocity, so it's going to be minus 1/2 times the acceleration. I'm going to use 10 for the acceleration. You can use 9.8 if you want, times the time squared. Okay, now we're not done with this. Of course, just like with the horizontal velocity, we have a component that's horizontal. Not all the velocity is vertical, only a component. So really this velocity is going to be v sine of excuse me, sine of 35 degrees times t. Well, you might be thinking, well, this doesn't really help me, Mr. Lindfest, because again, I've got now 3 unknowns. Well, the truth is, no, you don't have 3 unknowns. Look at the picture. It goes up a certain distance, and then it comes back down. So what would the displacement be vertically? I'm pretty sure I heard you through the computer. You said 0, and that is correct. It is 0. So that means that we can solve this now for t. Notice that I can now divide both sides by t, and when I do that and get rid of the square, get rid of the t here, I can now solve this pretty easily. 1/2 of 10 is going to be 5. Now you can see why I'm so lazy and I use 10 all the time. And now I can solve this for t, and t is going to be equal to, I really hate that it changes. There we go. t is going to be equal to v times the sine of 35 divided by 5. So I can plug this equation in over here into this equation. And this is what I get then. So realize now I have exactly one unknown, and that's the v. And so simplifying this a little bit, I get 7 equals v squared times cosine 35 times sine of 35. And then, of course, I have to divide this whole thing by 5. And then I should be able to figure out what this is pretty darn easy. I can solve this for v. So I hope that helps you out a little bit, and I hope that you start to feel comfortable with me, that you can tell me, hey, if there's something you just don't feel very comfortable about, we can do more of these little video lessons so that we can kind of stay up with stuff. Looking at the next one, part B, it's looking at how many liters of water per second. Really what I would do is figure out how many meters cubed per second first, and then convert it into liters per second. That's more important to figure out the meters cubed per second. Notice in part A there are 4 heads, so really you're going to, where you have Q equals A times V, so the continuity principle, you're going to have to multiply 4 times A times V to figure out what the flow rate is through the main delivery tube. And then once you do that, you should be able to figure out part C fairly simple. So again, I hope this helps you out a little bit.